Very good morning, everyone. So, welcome to the class. As some of you might not be knowing that this is the subject, which is the subject and what class we are starting. So, I'm going to introduce all details about this, and I'm sure that you will be learning a lot through this subject in a big way. So, uh, as per timetable, also, you might be knowing that this is a subject for algorithms course. To be precise, we call it as a DA, and sometimes it's called as DA, sometimes it's called an ADA, but ultimately it means design and analysis of algorithms. Design and analysis of algorithms. So last semester you have already studied data structures. At some other places, this is also called as ADA, analysis and design of algorithms. So more or less the same name, universally followed either DA or ADA. And in all engineering throughout the world, this going to be always taught. So you have already done data structures and followed by data structure. This is going to be next course, which is called as a DA or algorithms course. So collectively, these two subjects combinedly become the most important and most desirable subject combination for any computer or IT engineering. And from job viewpoint also, these are the most important. Most of the IT company placements, all interviews, all written tests, definitely you are going to see some role of these two subjects. And nowadays the trend has changed, rather, that even if you have an experience of many years and maybe after 10 years also you go for interviews for a new selection to a good company, still you can expect one round of technical round on the data structure and algorithms combined. So even if after 5 years, after 10 years, you want to switch a company, you probably have to revise the data structure and algorithms subjects. So your programming in C or C++, whatever you have done for this subject knowledge, programming in C will be useful. Plus, followed that you have already done data structures, that also in C you have done. And now we are going to do the algorithms implementation in C. Mostly we are going to target, and that is going to be the overall focus of this subject. But in this subject, as it suggests, that we are going to have not only the implementation, we are going to touch upon two aspects. One is called as a design, another is called as analysis. Design, more or less in data structures, whatever you've done, you probably have done design part also, but although you might say that you have done coding, but when you say the word coding, actually it involves a lot of related activities through the design of the algorithm also. And design primarily means that you have to make the logic of this. So you have to find out the detailed stepwise logic, detailed step-based logic or stepwise logic you have to plan. So I say it is called as a micro planning, micro level or micro level details, then macro level. So once this code or was based on the working understood is what we call as the design aspect. So just 1 second. So programming, you normally, if you know the already developed code, if you have understood the code and then you try to give the syntax, well, that's not a design. But If you know the working only, if you know the methodology, if you know the steps, if you know the logic over an example you have understood, but then you try to develop the detailed stepwise logic of this in form of some pseudocode or some kind of a detailed algorithm, and then finally you put that with syntax, then it becomes a program. Before syntax, whatever all that you do, all that is what we call as, I'll say detailed stepwise, all that what we call as is a design. So in data structure, you mostly studied the various algorithms or various pre-planned or pre-determined algorithms, and maybe you have just seen the algorithms and then implemented. Now we are going to understand that we are not going to see the algorithm, we are not going to study the code, we are going to study the working, and based on the working, we are going to design the code, design the logic. And then comes the second aspect, which we mean by analysis. Analysis means primarily we are going to do, it's a time and space complexity analysis. So time and space complexity computation will be done. Again, last semester in data structures, you have probably discussed something related to big O complexity notations. Big O notation you have discussed some way. So that was a kind of a complexity analysis. You might have just understood that yes, some algo has order of n, or some order has order of n square. These you understood without knowing how did we compute this. So we are going to now do for every algorithm the analysis also. What does that mean? That our target will be always to design an algorithm, also analyze it, and make sure that we don't waste the efficiency. Wastage or poor efficiency will not be tolerable at all. Poor efficient algo, poor efficiency, I will say. Let me just correct this. Poor efficiency will not be tolerable. I will not say even waste. I'll say poor efficiency will not be acceptable. So during analysis, we will ensure that are we wasting something? Are we unnecessarily doing something? Are we unnecessarily having extra complexity? Either space or time, we are going to look at that angle from every time. In data structure, you focused more on learning what are those structures, what are those standard operations. So earlier that you have done, now we are going to see various algorithmic approaches, various new data structures, and various design principles. So we are going to see all those things, new algorithmic approaches, and also the design of all those techniques, design of these, and then followed by analysis of every algorithm designed, every algo or every approach. So that is going to be the focus of our subject in this semester. Well, now having said that conceptually complexity is very important. So conceptually we always say that complexity is most important. So complexity is not to be compromised, and whenever we are going for complexity analysis, we will make sure that we are not going to compromise this. But from our lab viewpoint or our implementation viewpoint, we will be taking something more also into picture. Not only from lab viewpoint, from IT industry viewpoint also, we are going to do something special. Not only the complexity is important, but there are some more aspects also important. So what we say, what are those important aspects? There are some other aspects equally important to the complexity. First, I say modularity. Second, I say readability. Third, I call as a structuredness. More or less, this also gets covered indirectly here itself. And definitely, I say efficiency. When we talk of algorithms, primarily our focus remains on efficiency, but a good engineer, good IT developer, when I say, or when you become SDE, software development engineer, or SD developer, the various company will have different designations for all of you. So good IT developer has to ensure all four above. But in order to make sure that we also learn all good industry practices, we will ensure that efficiency never be targeted at the cost of above 3. Never to be targeted. Even if we are able to improve efficiency slightly by compromising aboves, we will never do that. So never to be targeted by compromising either modularity or structuredness or readability. So that will be the thumb rule in this semester. Of course, when you do competitive programming, later you will do CP, etc. You can think of doing faster coding, efficient coding, maybe the focus, only focus, but we are not going to do that now. In CP competitive programming, that becomes the only focus. So CP, some of you might be knowing the word, some of you might not be aware about. Let me share my screen once again. Fine. So we were just saying that we have the concept of competitive programming. So some of you might be knowing this word competitive programming, and some of you might not be knowing this. So competitive programming is a different kind of a programming experience as well as a practice with special tricks where your focus will come on faster and efficient coding, and that has to be the focus. But initially, before doing this, in this subject, we are not going to do this. Not our focus at present. For this semester, for this subject, our focus is not faster and efficient programming only. Our focus is taking care of all four aspects. Going one by one. What do you mean by modularity? Yes, modularity primarily means use modules, use functions. In C, you have functions mainly as modules. So when I say functions, not just functions, with proper parameters, with proper return types. How many functions, which functions, we will understand timely, and with proper return type. Proper return type. We have to choose, we have to have a reason why we are having this, why we are not having this. Secondly, the role of the function has to be defined. Why that function is being used. Why that function and a module? So thumb rule is each module should do one and exactly one work. Exactly one work at a time. Well, work itself is undefined. So sometimes you don't unnecessarily divide a module in submodules, but don't unnecessarily combine also. Don't unnecessarily, I will say unnecessarily divide a module into multiple. Similarly, no unnecessary grouping also. No unnecessary grouping of multiple works in a single module. So this is what we mean by modularity mainly. No grouping of works in a single module. For example, sorting module should only do sorting, nothing else should be done. Searching should be done as a separate searching module. If a module, if some functionality requires searching as well as sorting, then I should have a separate module for sorting, separate module for searching, and maybe another module which uses these two combinedly by passing the results, etc., etc. So no unnecessary grouping of works in a single module, no unnecessary splitting of the works in multiple modules. This is what we mean by modularity. And we will always try to have main to be mainly used for calling or supplying the data to the modules. It's used for inputs, outputs, or call to various functions. Main is not supposed to do so many other activities, or some modules work should not be complete, put into the main module itself, main function itself. So call to various modules. So this is what we mean by modularity. Maybe with time you will understand when we discuss through examples. Then second comes readability. Readability effectively is that logic of the working should be easily understandable, to be easily understood by reading the code, by reading or looking at the code. Means that don't write complex code. The statements should be as simple as possible. Code should be self-explanatory. I will simply say thumb rule will be that if you show me the code, in the lab, I should say, let the code speak, not you. Of course, now you can't say that code doesn't have a mouth, code doesn't have a tongue. So I mean that your explanation should not be needed. Code should be automatically understandable. So for that, of course, you have to use always meaningful names. You must have all variables to be properly named, not just say A1, A2, A3. I, J, K for the loops can be okay. But for other variables, all variables should be meaningful. Like n is well defined for the size used. But if you want to find out summation, name it a sum. If you want to say string, name it a string or str1, string 1. If you have some name, make it a name, not say n1, n2. If you have count, maybe count. If you have previous, name it as a previous. If you have next pointer, call it next PTR, like that. Not only that, along with this, you have to take care of writing the code in an indented manner. Indentation must be followed. And indentation doesn't mean that after you complete the code, you should do the indentation. Indentation must be practiced during typing. Once the code has worked correctly, then if you do the indentation through certain tool, then effective purpose or basic purpose of this is lost. It will help in a big way to identify logical mistakes. So it will be useful if you make a habit that I will never type a code without indentation. So logical mistakes will get caught if you are habitual of this. What does indentation mean? That statements which are part of a block, they are shifted right side in typing. They are shifted to the right. Shifted to the right by few spaces. For example, I say I am writing main. Now, all statements which are part of main, they should not start from here. Rather, they should start always after 3 to 4 spaces. Say you have here printf, you have scanf. All these statements are part of main. And whenever main will end, it will end at the same place. Similarly, I might have here a for loop. Now, as soon as you have a for loop, statement inside the for should be written here. After this, because it's a single line for loop, statement is over. Say now you have an if. It will come at the same level, this level itself. If some condition, let's say you have some statements. All statements which are part of if will be further shifted. As soon as over, you are back to this place. If you have else, maybe you will say else, whatever you have, the condition, you can put all those statements after certain place. Again shifted and again like this. So this is what we call as indentation. Remember, I repeat that during typing, make habit that you follow this. There are tools which will do the indentation after your code works, or automatic indentation also happens. That will not help you much. For example, if you are making a for loop and you typed here a equal to b plus c, if you don't have a good habit, you might write here if a greater than b, and maybe you have some statement here also, and then like this. And then you probably don't know whether you wanted this if statement to be part of for or not. Now, if you are a good programmer and you know that you have following indentation, you will always remember that while typing, I didn't put a bracket. I had only single line as a for loops part. And if I wanted if to be part of if for loop, then obviously brackets were needed. You will immediately recall that I want this if to be part of for loop, so that you will recall that I need to put brackets, or vice versa. If you remember that, yes, I don't need this statement to be part of for, then you will automatically write here if, and code will be visible that this is not inside for, it is outside for. And then remember, indentation will not affect the actual execution. You don't assume that if you have typed it right side, it becomes a part of for in execution. No. Execution will actually depend on the syntax only. If you have put braces, only then the statement will be considered as a part of if. Typing if after 3 spaces, typing if at inner indentation level of loop doesn't make it actually part of loop at all. So don't assume that a typing at inner indentation will make it a part of execution. Doesn't mean that it actually happens. So typing if at inner indentation level doesn't lead to equivalent execution. Doesn't mean that execution will happen like that. So execution does not get affected in that process. That does not mean that execution will happen like that. So indentation is only for readability purpose. It doesn't affect execution. Third, structuredness. Structuredness means always follow the basic structured programming. No abrupt breaks, no abrupt jumps. We must do always structured programming. No breaks, no jumps, no abrupt control transfers. For example, we can always say that you are all knowing a statement, something like called as a go-to. Structured programming says forget go-to. Never use it because it goes unstructured. So go-to is never to be used at all during the programming. Similarly, other aspect comes that either I have a control to be totally nested inside or parallel, no in between jumps to happen. Like I have somewhere here, another logic, if I have a nested loop, should be totally inside or can be one loop parallel, another loop parallel. This is also okay. This is also okay. But if I have some way of writing the logic that you have somewhere here, then logic shift somewhere here, from here logic shift somewhere here, this cross connections mean unstructured programming. Similarly, wherever you should use for loop, at that place using while will be not so good choice. Wherever while was to be used, using for there, not so good choice. All this also becomes a better way of readability as well as good programming principles. Like I know how many times fixed times loop execution is guaranteed. Fixed time execution of the loop is known to me. Say I say n-1 times always. Then I should use a for loop, not while loop. Because I know precisely I should write something like for I is equal to 0 to n-2 or for I equal to 1 to n-1. On the other hand, say I say loop may execute may execute 0 time or 1 time or maximum n minus 1 time, can stop in between based on condition, as per condition. If it is so, then use while loop. Say while some condition, while I less than n minus 1 and say less than equal to also could be there, and something. For loop used is not a good choice, because the for means, although you could write, but I prefer to write it as for equal to 1, for less than equal to n minus 1, I plus plus. Straight away tells exactly n minus 1 times. So for situation like this, for loop is not a good choice. So all these principles to be taken care while doing programming, and using this, we will be doing all basic programmings for this. Coming class, we are going to start with talking of insertion sort. Insertion sort, you have already done the coding, so less focus on design, but more focus on analysis. We will understand more clearly what do we mean by analysis. Later, we will start focusing on both aspects, design plus analysis of every element. Because insertion sort you have already done, so we will be focusing more on that aspect in the coming class. And we will understand what does analysis actually mean. So let me stop here and